I need this. Okay, hello everyone. Thank you for joining this workshop. Thank you for joining the third iteration of Golf Bank's Datathon. See a lot of people there in the back. Can you see me? Can you hear me? So this workshop is about modeling with Python. We're going to be introducing Python. We're going to be introducing you to data science. We're going to be talking about machine learning, and finally, the hot stuff, Gen. So, in the world of data, every bit tells a story. The data scientist is the archaeologist, unearthing stories buried in the sands of information. Kind of generic, cheeky, but it took me 11 parts to come up with that. It's fine. Do you know what was that? That animation. Thank you. So about me, my name is Ahmed. I'm an assistant professor in the Public Authority for Applied Education and Training. Currently, I do part-time as a data science consultant and AI engineering. So AI engineering is also a new field right now. It's a blend between data science and machine learning as well as software engineering. So there's a lot of going on with AI engineering. I also do applied AI research. Currently doing some things in bioinformatics. So we have a few conference papers already submitted, but we're waiting for acceptance. Okay. So the agenda for now is we're going to be talking about Python, okay? And we're going to be using let's say a toy example plus. The toy example. We're going to be using the bubble sort. Anyone here computer science? And anybody here knows bubble sorts? Who thinks bubble sort is a good sort of algorithm? You think it's a good sort of algorithm? Actually, it's the worst sort of algorithm. But it's the easiest to implement. So that's why we're going to be doing the code walkthrough of the bubble sort. All right. And then we're going to do an introduction to data science using as a framework the data science lifecycle. And we're going to be using, we're going to be doing a Google Colab. Anybody heard of Google Colabs? Yeah. So probably the competition is going to be the de facto tool we're going to be using to submit your work. So it's a good idea to familiarize yourself with. All right. So let's get started. So first things first, Python. So where is Python used? It's used in artificial intelligence, machine learning, data science, web development. It's a big use. Everywhere. Web development, even game programming. All those you see shot is much better utilized for game programming. But in general, Python is used even for teaching programming. It's an easy to use language, easy entity. In addition, it's useful language. So highlighting artificial intelligence and data science is what we're going to be using for today. All right. So who invented Python? Guido is famous for. He's now working for Dropbox, and he invented it in 1989. It was supposed to be an easy language. That was the intention. So there was some hardship with other languages such as Fortran, Perl, etc. So the invention of Python came about for ease of use, but it didn't gain popularity until I would say maybe 14 years ago, 15 years ago. I started off with Python 2.2, 2.7, and now it's considered legacy. Now we're using 3.6, 7, 8. Now current iteration is 3.12. One of the good things about it is that it's a multi-paradigm programming language. So It uses object-oriented programming, it uses structured programming, functional programming, any type of programming. Now, I know a lot of people might not understand what I'm talking about, but we'll go into the mental model of how Python works and how to think about programming in Python. So this is essential. If you have a proper mental model when you're programming, rather than just teaching you the syntax, then it's going to be easy for you to understand any library of code. So once we get into, for example, NumPy, pandas, show hands, people have heard of those. So one of the things is in this day and age, specifically with the emergence of large language models such as OpenAI's GPT, now it's more about the thought of creativity and how to come up with ideas and how to solve problems, rather than being, don't want to be a framework engineer, want to be a software engineer. So starting off to become a good software engineer, you have to have a proper mindset and have a proper mental model when you're talking about going forward. Now, another thing is it's dynamically typed versus statically typed. We're going to talk about the differences there, but very briefly.
So I don't like to talk just one way. So who can tell me what batteries included means? Okay, in the back. Do we have a second mic, by the way? Or no? Okay. So what does battery included mean? Okay, so I'll paraphrase what he said. Everything's included. You don't have to build anything from scratch. Or let's say a lot of things are included. You don't have to build many things from scratch. You don't have to reinvent the wheel. Okay? Except for bubble sort. You'll have to reinvent that one. All right. So Python's popular. Every year I've been using the same slide. And it never changes. It's always the same. Python is always the most popular programming language according to the to-buy index. So comparing from 2024 to 2023, still number one, still holding the top spot. 2022, 2021. I've been using the same slide for, I think, 4 or 5 years right now. Still the top language, most popular language. Because, as I said, it's used everywhere. And as I see here with the trend, it wasn't the case, let's say, maybe 10 years ago. It just started to emerge to become the most popular language. Surprisingly, JavaScript is number 6 and 7. Of course, I'm not hating on JavaScript. JavaScript is also an excellent language. It's just different. And C is still popular, believe it or not. So it's number 2. But there's talks now that many companies, let's say Windows and Linux, they're going to be changing their operating system kernel to another language called Rust, which is not yet popular, but is going to gain traction soon. Okay? So another famous slide that I always like to use, just to convey the ease and how simple the language is. So just printing out hello world. You always start off with hello world with program. Not today, we're not going to do that. In C, you have to do all this including of the standard IO header. You have to create a function called main, and then you have to return 0 with the main. Who knows what a return is? What is return? So some people know function, know programming languages, right? Okay, good. So even with a non-programmer, if you go all the way to Python, you'll see it's very English friendly. Immediately just says print with quotes, hello world. You're done. That's it. JavaScript, a close second. You have to do console.log, but not more. Okay, so if you haven't done so already, their website, python.org. Currently, the latest release is 3.12. Has many nice new features. I haven't played around with them. I'm still using 3.10. It does the job for me. Other sources of Python is, which the one I consider my favorite. And I suggest if you haven't downloaded Python already, use this source, which is Anaconda. So anaconda.com, you just have to sign up, give them your email, and it's a free download of their Anaconda Navigator. And the nice thing about the Anaconda Navigator or Anaconda as a whole, as an ecosystem, is it includes many tools and all the packages that you need in data science. So for example, you have SciPy, you have TensorFlow, PyTorch, Matplotlib, Pandas, etc. In addition, you have Spider, which is also my favorite IDE, Integrated Development Environment. Jupyter, I don't like it that much. Google Colabs is much better, for me at least. But it does the job. It does the job as Google Colabs. Okay. All right. Google's Colab is another place where you could also have a notebook and where you can write your Python programs. And the latest version that also it includes, as they say in Python, pip install packages. And this one, you don't have to install anything. Everything's in the web. So it's all online. All right. So let's talk about programming first in general. So about programming, information that is being analyzed, such as words, numbers, etc. That is considered data. There's many types of there are numbers, images, you name it. Any type of data structure considered data. Okay. Now, what is an algorithm? An algorithm is a computational procedure for solving a particular problem. And this is what I consider the axiom of programming. Basically, any type of program you have, an application, it's made up of a bunch of smaller axiom problems, which is the prior algorithm. Let's put algorithm and output. Let's say axioms of programming, which is a bubble sort. And bubble. So our input in this case, the data, is going to be a bunch of numbers. So I have 5, 3, 9, 7, 6. But quite small number. The desired output or the numbers being sorted. So in this case, 5, 6, 7, 9, which is sorted from the unsorted list, which was the input. And now the algorithm will be the bubbles. Now first, we have to decide. We have to have many decisions. One thing we have is the array. Okay? So what does an array do? It houses many elements within a single object. Notice the theme. It's always about snakes. Or insects. Spiders and insects. Okay, good. But I was going to be embarrassed if there's an opening. Oh, it's taken a long time. Show you Google Collapse. Okay, so let me open up a new notebook here. So one of the things that you need with Google Colab is, at least that's what I found. So you need your be stored in your Google Drive. Okay, for example, let's say this is shop, okay. And then here we're going to be having cells. Okay, so types of cells. Going to be the coding for the code blocks. So for text, we're just going to write like this is text. Formatting, you can bolden it, you can increase the size, you can do many things. This is a head. Okay, so let's add another one here. And the nice thing that for Google Colabs is you can also generate with AI. So now you can generate code with AI. So you don't have to, I don't want to say waste your time. You just want to do things quickly. So for example, a connection with antigen. Code is going to work, test it, but I'll just show you that. Okay. And not only that, but it's also one, this is two, three, and suggestion four. So this, you can do this any So I have a variable, I'll call it my list or my numbers. Okay. And then I'm going to be creating a list. So how do you do it in Python? You add square brackets. And then we're going to add some numbers. 12, 15, 6, 7, let's say 15. As well. So now I have my numbers. They're all unsorted. They're all stored in a collection, and I call it the lists. Okay. And if I run it, so I can run here in Spider. Okay. Now, if I go to the variable explorer, unfortunately it's not working. But if I go to my IPython console here, and I write my numbers, okay, I'm gonna have those numbers. In addition, I can also access particular elements in the list. So this is called, each one of them is housed, and the address for that house is called the index. In Python and many programming languages, the indexing starts from where? Who knows? 0. Thank you. Starts from 0. Some languages, no. They start from Visual Basic. They start from 1. If anybody's familiar with MATLAB, also they start with 1. Where do you start from? You start from 1, right? Start from 1, yeah. Okay. Now, how does bubble sort work? So let's go through the algorithm. Dry run it, or we so what happens is the numbers, they're going to be bubbling up. Okay. So what I'm going to be doing, then they're going to be swapped. Okay. So initially, it's going to be 12, 15, 6, 7, and 1. What do I know that I'm going to be comparing this one and this one? That's number 1. So the contents of 0 and done. So how do I know that this is there? Let's do this here. My numbers, 0 has the 12. My numbers 1 has 15. Okay, so I'm going to be comparing them. Compare. Hmm? Their own sort. So how do you compare? Okay, before I do an answer. There's a I'm looking for. Go ahead. The if statement, exactly. Thank you. Which is universal with every language, right? If statement. So what we're going to do now is we're going to compare these two numbers. So I'm going to say this. I'm going to say if my numbers 0 is this is the greater than sign. My numbers 1. Okay. So at the end of an if statement in Python, what you do is you put is going to be inside the if statement. Some languages that's inside the if statement. Here we're doing the opposite. So I'll be referencing other programming languages just so that if people have backgrounds in other programs, that it will become more familiar to them. Okay, then what do I do? This is true. No, not yet. Swap, right? So how do I swap? Huh? Okay, creating a temporary variable. Let's do that. What do I do with this temporary variable? What do I assign the temporary value to? Okay, let's do that. My number 0 Okay? I don't. One is enough. Swap? How do I swap? Do I write swap? Ah. Okay. My number 0. Okay. So now it's okay for me to override what my number 0 is because I stored it here in the temp. So it's not going to get lost. It's going to be there. So it's going to be equal to my number 1. Okay, let's write down my number 1. Okay. And then what do I do next? My number 0. My number 1. Yes, my number 1 will be equal to 10. Exactly. That's a swap. That's a swap in every language, right? Python does it differently though. This is the old way. I'm having errors. And then numbers. All right. So Python does it a different way. Get all that. I'm just going to do this. My numbers 1 equals my numbers 1, comma, I lost the text is too big. Numbers 0. Okay. So what's that doing in effect? So if I had, for example, A equals 5 and B equals 60, okay, A, B, and if I do this 40, to B, you can do that in Python. You can also do this. 2 numbers are. I'm going to say the new A and the new B is going to equal to the old B and the old A. So now B is going to be assigned to A, and then so this is an easier or nicer or more Pythonic way of doing a swap. Okay. All right. So some people are getting bored. Maybe this is too easy. What's next in a bubble sort? What do I do? We said that the numbers, they slowly go up. What do I do next? I compare 0, 1. It's still not sorted. So before the loop, with this small example, what am I going to do next? The next one, exactly. So after this 2, and then the 2 and 3, and then the 3 and 4, and then the 4 and 5, and then I stop. No, I don't stop. There's one. Then I do another round of the same and over again. Now, if I want to do this kind of stuff, what structure, some of you who know programming, what structure do I use? I use a for loop, exactly. So let me do this first, so that it's clear for everyone. Oh, Control Z. Okay. So I'm going to be comparing 0, and then here I'm going to be comparing 1 and 2, right? Of course, this is going to take a long time, right? I'm going to, with this small example, it's not going to take that, but now like with 1,000,000 elements, it's going to take a very long time. So an easier approach is, let's start off with just assigning integers or a variable, sorry. So I say here I, and then he'll say I plus 1. And then here I'm going to say I is. So now this one is going to be referencing 0, and then this one's going to be referencing 1. And do the same thing for all of them. Here I'm going to put also I, and here I'm going to put I plus 1. But of course, here I want I to be 1. So what I do, I say I is equal to I plus 1. The old I plus then it becomes 2, and so on and so forth, right? Okay. And if I want to do this with just if statements without using a for, this is going to take me many if statements. Not only that, it's not going to be versatile, right? It's not going to be robust. What if my list is 1,000,000 elements? What if my list is only 10, right? So in this case, I'm going to be using a for loop, okay? Now to save time, for I in, okay, and then let's talk about this also. And then my numbers. Okay? Then I'm gonna print I. Okay. Who's here familiar with for loops? Okay, can you tell me what the for loop is doing? Exactly. So it's going to be iterating over each and every element. So the I is going to be containing the number 12, then the number 15, then the number 6, then the number 7, and so on and so forth. If I run this, as you can see with the print here, I'm printing each and every one of them. Print, 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 print. So what I'm going to do is this. Instead of doing my numbers, I'm going to do a different approach. I'm going to use something called a range. Okay. And then in the range, I'm going to be adding the length of my numbers. Okay. Okay. And now, if I run this, people who know Python, what's going to happen here? Get the index. Number to what number in this case? Exactly. Now, why did I choose this approach rather than going fix instead? Sorry? Yeah, I'm not used to a big hall. I used to teach like in smaller halls, so I can hear everyone, but now it's going to be much tougher. Go ahead. Okay, so you're almost there. That's correct. I'm going to be using the index because I'm not only referencing the current element, but I'm also going to be referencing the next element. Okay, because I'm going to be comparing both of them, right? I'm going to be, so what's going to happen is I'm going to say if what? So no, what am I comparing? You said I'm comparing two elements, right? And the element, what's the name of the variable? My number. So what am I comparing? Why did I mention I previously? Well, I is giving me the index number. 0, 1, 2, 3, 4, 5, 6, 7. Okay. So first thing I'm going to be comparing what with what? Huh? No, not I. What am I comparing first? I want concrete, let's say, examples or numbers. Huh? No. Yeah, you're right. But now my question is, what am I comparing? I'm comparing 0. Okay. And then next, I'm going to be comparing 1 with 2, and then 2 with 3, and then 3 with 4, etc. So I'm going to be comparing the contents of the address 1 or 0. Okay. In this case, initially it's going to be I, which is 0. And if it's greater than my numbers with I plus 1, the one next to it, then do the swap. And we already wrote the code for the swap, which was going to be my numbers, I, comma, my numbers. I should have chosen a different name for the variable, but now I'm stuck with it. Equals, and then let's just do a copy paste here. So you're just using X, which is bad practice, by the way. Never use a variable name that has no meaning. Okay. Here is going to be I, and then here's going to be I1. Okay. All right, let's try this out. Let's run it. Okay. Oh, something wrong happened. The nice thing about Python is it gives you the exact error, and even 3.12, I've seen, I haven't used though, has really good error, index error. And it tells you in plain English, this index. Yeah. Exactly. Exactly. You have it. Yes, exactly. Both of them are correct. You're starting off with 0, and then you're going up to, right? 0, 1, 2, 3, 4, 5. So I, 3, 4, 4, my numbers, yeah, my numbers for 5 is going to be 50. And then 6, actually is going to be 0. 6 is out of range. 50 because I did the sorting already. Let me, you know what? Let me just do this. Let's remove these for now. Okay. Run the same thing again. Okay. 5 is going to be 1. Okay. And then if I do 6, it's going to be out of range. So here, what's going to happen is I'm going to be referencing 6, which is out of range. So now I have to fix it. And this approach, this is important. You never solve the problem completely from the get-go. You build it up. So first we started off with the if statement, how it works, and then we're starting with the for loop. Bubble sort requires not only one for loop, but it requires 2 for loops, one inside the other. Because initially, and this is what I'm going to do right now, so I'm going to do this -1. That means just go up to 4, and then the okay. So I'm going to run this. And it did something. Let's see what it did. Okay. Notice something here. This is the original one. This is the original one. And this is the new one. What happened? What statement can you tell me for sure that it happened? Not completely, no. It didn't do it for all of them. But there is one truth that happened. No. But something about the last index happened. Value. Thank you. So the biggest value during the first round went all the way up. So now the 50 is the last number. So we guaranteed in the first iteration that it completed and it did it again. So now we want to do this multiple times. We don't want to do it this one time because with one time, I didn't get it to be sorted completely. Okay. I still have 1 here. I still have 15. It's still not sorted. But the only thing that is guaranteed is that the 50 is at the very end. So what do I need to do? How many times do I need to run this? 1,000 times, 50,000 times, 1 time, huh? 5? The length, thank you. You run it according to the length. So for example, this is 1, 2, 3, 4, 5, 6. I'm gonna run it actually not 6 times, I'm gonna run it 5 times, okay? Because this is what I did here. I did len -1, so I ran it 5 times. And I'm gonna do it 5 more rounds. So total, how many steps did I do? Or how many times did I call the if statement? How many comparisons did I do in total? For this one? 5 times, exactly. So someone here answered 5 times 5, so it's going to be 25. What if I had a size of 20? How many times do I have to do this if statement? No. Huh? No. If I have 20, the size of my size list was 20. How many times do I have to do comparisons? Huh? 20 squared. Okay. So in computer science, we say that this is the complexity of the code of this algorithm. It's considered O(n) squared. So n is the size of this array, and since it requires n squared times comparisons, it's an O(n) squared algorithm, which is really bad. Okay, it's polynomial, it's really bad. So let me finish up the code here, and then we'll take a break after this. So someone help me. What do I do here? For what? For I? Do I want to do I? For J, let's do J. For J in range, okay, length. Okay. Actually, just copy the bottom, right? Okay. So the number of rounds I'm going to be doing is equal to the number of elements minus 1. Okay. Of course, even bubble sort, we can improve on it, but still remains to be n squared. Okay, and I leave that as an exercise for you during this 10 minutes, okay, while I go drink water. I want you to improve on this bubble sort, okay? Two things you need to know. First, one thing is, I know that the last element reached, or the largest element reached the very end in the first round. The second round, the second largest element is going to be reaching what? The second to the last, right? So that means internally, do I need that many rounds? Okay. So what do I fix here so that it reduces the number of steps? Minus J. Minus J, exactly. So this 0, nothing happens. Same thing. Next one, we're going to eliminate one of them. So it's going to be one less, and then one less, and one less, and one less. Okay? One more thing. What if this is divided? Everything is sorted. What do I do? Do I continue my computation time and computation resources to do more comparisons? Sorry? Break. But when do I break? When? What is the condition for me to break? How do I know that the elements are already sorted? You're right, but how do I know that the elements are already sorted? That's the keyword. If I go through the whole list, so I go through a whole round, so I still waste one round, which is fine. It's better than wasting too many rounds. I go through one round, and then in that round, I have no swaps, then I know for sure that, you know what, I'm sorted, I should just leave. And leaving is called breaking, okay? So we have another keyword, and these are called keywords, by the way. Programming languages in general, they have keywords. For example, and they have even color coding in the integrated development environments. It's red here, for example, or sorry, blue here, for example. That's a keyword. This one is a keyword for a function, or let's say this is not a keyword, but this is a function that is already pre-defined in Python, which is called range. Another one is length, and so on and so forth. Okay. So what I'm going to do is I'm going to create a new variable. Okay. Called it sorted. Actually, sorted is a bad letter, a bad one. It's a reserved function. Let's call it S. S is equal to false. Okay. And then when I was talking about Python and variables and everything's an object, each has a type. So for example, if I ask, what is the type of my numbers? It will tell me. And then if I do this here, and I ask the same question, what is the type of S? It's going to tell me blue. Okay. So in Python, you can, even types are a type, by the way. Even types are a type. And why is this important? Because when you go to the frameworks, when you go to NumPy, when you go to scikit-learn, when you go to Flask, whatever, they all have types. Some of these types are from the framework itself. So the framework has several types. It has several types. How did they do these types? They have a thing called the class. So the class is the type. Now, for example, S here, that's already predefined type or class that I did not design, but came along with Python. When you go to the frameworks, you'll see that these are already developed by other people when you're using their frameworks. Okay, so let's do this and then we'll take a break. So first thing is that sorted is false. And now if there was no swaps, so here, actually let me change the name. Not sorted. Okay, not sorted. So not sorted is true. Okay, so that means initially I'll assume that it's not sorted, and then when I go here, to the if statement. If this happens, if this becomes true, then I will say my not sorted is equal to false. Okay. And then what I'm going to do is here, when I'm done with the loop, with the first round, I'll ask if not sorted is true, okay? Or sorry, if it's false. If it's false, wait, I'm now confused. Someone help me. Not sorted, it's true. If this happens, then it's false. If it's true, let's do that. Yeah, if it's true, then you break. Yeah, so I had a brain just, okay? Then you break. You break completely, okay? And let's try this out. Print. Let's print my numbers. There you have it. It's sorted. Okay. All right. We'll take a break. 10 minutes. We'll be back in 10 minutes. So 7:40. And we'll continue talking about the data science lifecycle. everyone. So we're done now with the Python part of this workshop. I hope it was useful. And now we're going to go to the theory as well as we're going to go into code. Okay. So we're going to talk about data science. Okay. This is why we're all here for, right? We're here for a datathon. Data is in the name. Okay. So data science, what is data science? Data science, in essence, is you want to extract knowledge, information, something useful, okay? And insights from structured and unstructured data, okay? So structured would mean, for example, a database. Unstructured data would be maybe some repository of, or a data lake, for example, that has many types of data. Now, one of the things about data science is that it's a multidisciplinary field. So it uses the scientific method. So if you want to prove your point, you have to understand some of the statistics involved, okay? There is algorithms, so data scientists are also programmers, right? And you have to analyze complex problems, okay? So there's all the things. So you also have to know, have an understanding of what problem you're trying to solve. You have to have some sort of domain expertise as well, or at least have a contact with the domain expertise. So data scientists, we wear many hats, okay? We are computer scientists, we're statisticians, mathematicians, business knowledge, etc. Okay. So this is the data science life cycle. It has many stages. Now, this is not set. This is not set in stone. Even the iteration of the cycle itself, okay, it doesn't have to be in this order, but it is recommended for it to be in this order. Now, of course, these are just iconographies. We don't know what they mean, but I'm going to go into each one of them separately. So I'm going to start off with the business understanding of your problem, okay? So what is business understanding? So you want to understand the problem itself. What are you trying to solve? You want to define your objectives, and you want to formulate initial hypothesis. Now, one of the things is, with the business understanding, you will understand whether you need machine learning. Okay, we'll talk about machine learning soon. Or whether you need just some sort of deterministic algorithm that will solve for you the problem. Not everything needs to be solved with machine learning. Not everything has to be solved with deep learning. Sometimes simpler algorithms will suffice, okay? Why do we do this? So we want to align the data science project with our business goals, or with what we're trying to achieve, okay? So we want to ensure that the results are actionable, and we want to ensure that the results are relevant to our needs, or to the business needs. So I categorized business understanding, so I just made it like, let's say, categories into what we're trying to achieve. So if we want to achieve something that is related to how much or how many, etc., okay? For example, I want to understand or predict the housing market, okay? Then it's going to be a regression problem, okay? If I want to know, do some sort of classification, simplest one that we use on a daily basis, email. You want to classify it. Is it spam? Is it legitimate email? That's using a classification, which is a categorical type of problem. And then there is also one that is for clustering, or let's say grouping, okay? So for example, I want to see if newspaper articles are related to one another without labeling them, okay? So this is, for example, unlabeled data or unlabeled information. But I know that they're similar to each other, and therefore they're clustered together. So this is a clustering problem, okay? And this is also considered an unsupervised. We'll talk about supervised and unsupervised data. And then there is also anomaly detection. So anomaly detection is something on the fringe, something outside, something weird, something off. An example of that would be fraud detection, right? So if there is some sort of, if there are a bunch of transactions that seem off, this is anomaly detection. Which option should be taken? This is recommender systems. So for example, when you're shopping, this is like a $1 billion industry, right, with recommenders. And not everyone gets it right, but this is huge. So giving recommendations. So deciding whether you would be shopping at a certain store, what is your demographic? Will you be shopping there again? Will you be visiting that website again? That is all part of the recommender system. And then the new one, I wouldn't say the new one. I mean, since the beginning of GANs, for example, generative networks. It's generating new information. Okay, so this is now a different domain right now. So now you're creating a new sample data. Okay, you can think of it, it's sort of reverse in this case. So the input and the output are going to have the same data type. They're going to be the same in this case. So this is generation, and this is part of the Gen AI part. All right. So once you have an understanding of what problem you want to solve, or maybe initially you don't, okay, but that's okay also. Then what you want to do is you want to see your data that you'll be collecting. And in the Datathon, you are going to be provided data, and you're going to be collecting it. You're going to be, in the Gen AI, you're going to be doing the same thing. So both tracks are going to have the same approach. Although, no, with the Gen AI, it's going to be kind of a different approach than the data science one, data analysis. So data collection. Oh, sorry. So what is data collection? So you can collect data from various sources. They can be files, databases, streams, or they can be generated, sometimes you don't have enough data, and therefore you need to generate the data. So you augment the data with the already data that you've collected. And without data, you don't have AI, by the way. AI is based on data. Yeah? Okay, let me correct that. The current AI systems, the current generative AI systems require data. Old style AI, the traditional AI, when we had like A-star search or whatever, those, they required simpler algorithmic approaches where it was more, or expert systems, for example. Maybe people who are my age, maybe they can remember expert systems. They were also considered AI, but it was not dependent on data. But the current AI landscape requires data. Okay, so this is just an extra tidbit. Okay, so why do we do this? So we need quality, but we also need quantity. So these two things are important. Quality is important because if you give it garbage data, there's a saying that says garbage in, garbage out. No matter what your model is, it's always going to be producing garbage output because you didn't give it quality data. So this is important. Quality data is important. And it impacts the potential insight and accuracy of the model solution you're trying to make. So this sets, let's say, the foundation for data analysis or analysis. So how do we collect data? There's several approaches. Okay, I'm not going to give away anything right now, but we will give you an approach for you to collect the data for this competition. So there are APIs. Okay, so there are now lots of services that give you the API, the interface, so that you can call the service, and then the service responds back with data. So this is the API approach. There are CSV files. So CSV files are just normal text files that are comma delimited. You can open up in Excel, JSON, Java objects, XML, although less used now, XML, it's mostly JSON. And then you have now data lakes, which are unstructured data, okay? And then you have data warehouses. So they start off with data lakes, and then they go to the data warehouse, and then they become structured, more clean, etc. And then, of course, there are web scrapers. And usually websites, what they do, especially those that provide an API, they don't want you scrapping their information. So they always have some sort of protections. So web scrapping is another one. So you take in the HTML file from that website, and then you parse it, and then you get the required data. All of these, of course, there are tools for in Python. Okay, and we're going to show some of them soon when I open up the Google Colab. So we have requests, which is sending an HTTP request, and then you get back a response. Beautiful Soap is another one, but this one parses the HTML itself. Scrappy, I've never used it before, but it's one of the most famous web crawling frameworks. And then there's also SQL Alchemy, which interacts with structured databases. So like, for example, an SQL database, but this one is using an ORM, okay? So an object relational I think management. So you don't write SQL commands when you're using SQL Alchemy. You use some sort of types and objects, etc. So it's kind of different, but it manages the queries nicely. Okay. All right. Next, so you've collected the data. Now what? Most of the time, data is unclean. What does unclean mean? it's unsorted, missing data, the format is incorrect, right? So then we go into the data cleaning part of things. So one of them is, as I mentioned, missing data. There is inconsistencies. There are anomalies, but not due to the data being an anomaly, mostly because the data was incorrect. Like someone is 5,000. That makes no sense, right? So that's dirty data. There's something wrong. You have to fix it. How do you fix it? You clean it. How do you clean? Either you remove the data, right? Or you average it out, okay? Or you try to figure out some other way to handle that missing data, okay? And this is important again for the insight. So improving the quality by cleaning the data, okay? And usually data cleaning takes the longest time. Okay, it's not the model construction, it's not, it's the cleaning. A lot of it takes even manual work. Now, with large language models, there are ways of cleaning data by using them. So another tidbit for you guys when you're doing this competition. Remember, you have a very limited time, okay? So figure out how to clean the data. Again, crucial for accuracy analysis. If not done, it will be misleading results, poor decision making. So data cleaning, the infamous pandas, it's a Python library for data manipulation. It uses a table-like structure, right? Data frames, they're called data frames. So this is pandas. Another one is if you want to do the manual work or semi-manual work, you can use MS Excel or Google Sheets. Okay, so you can visualize the data itself rather than using pandas. Although pandas, if you use it in Google Colab, it does a pretty good job of visualizing the data. There is then Tableau. So the people there, they're using Tableau right now. This is another way of cleaning the data. And then there's also Trifecta. The bottom two I've never used, so I don't know. AutoClean is a good one. It's a Python package as well that uses, that is good at cleaning the data and does suggestions for you for cleaning the data. Okay. Oh. Okay. So after we have the data, it's all cleaned up, it's all sorted, now it's structured. Now we want to do some analysis and exploration, also known as EDA, exploratory data analysis or data exploration and analysis. So this is the brainstorming session. And in this competition, you are going to be graded on your EDA, okay? How you're going to be taking the data, how you're going to be extracting insight from this data, okay? And extracting information or let's say meaning from this data. So this is important, okay? You can use statistical methods and visualization tools, definitely visualization tools. Definitely going to be using visualization tools. It is brainstorming, it is unstructured. You have to try different things. You're going to have to figure out if there is patterns, if there are trends, if there are relationships between different features, or in this case, columns of the data. Okay. So now I already gave away some things about the type of data that you're going to be getting. So why do we do this? We generate hypotheses, we discover insight, and it guides our choice on which modeling technique we're going to be using. Okay. So on this stage, even in the competition, then you'll figure out what models should you be using. That, and of course, the business understanding. Okay. So some tools, there is a Python package called Data Prep. Okay. This is a Python package for analyzing, preparing, and processing data. Calib is another one, and many visualization tools. Like, for example, Matplotlib is one of them. It's a very famous package in Python. There is Plotly, Seaborn. Okay, these are all packages that are good for EDA and visualization. Right. All right. Next is the feature engineering part of things. Now, one important thing about feature engineering is you need domain expertise, or at least semi-domain expertise, like have some sort of understanding of the problem, have some sort of understanding of the data itself, so that you can figure out what columns or what features are important and what are unimportant, and which ones are correlated together. There is some relationship between them, okay? Or figuring out new features. Okay, so it could be an aggregate of two features that gives you more information. Like, for example, let's say the yeah, in real estate, you have the width and the length of the land, but you don't have the area. The area is more important in this case, or let's say very important in this case. Not, yes, very important. So then you create a new feature from those two other features. Okay. So features, you can select features, you can drop features, etc. Okay. And the features in the end, whatever features you've decided on. Now you're not going to be explicitly graded on the features, but the features that you decide on will highly affect on the performance of your model. Okay. So this is important. Okay. So enhance the ability for the model to learn from the data, then make accurate predictions and classifications according to the problem, of course, of the data. Okay. So how do we do this? We do feature selection, as I mentioned earlier. You remove unnecessary features, unnecessary columns in this case, and that therefore reducing noise, reducing unimportant data. So some data that is just in your model that is not useful. So it takes, let's say, more weight, or let's say takes up weight, takes up space in your model, and you don't want that. So that's why it's better to keep your model, or your, let's say, your input lean. Okay. Keeping it lean means what? Means removing unnecessary features or unnecessary data. And as I mentioned earlier, also creating new features from existing features. So that's feature construction. All right, so what tools do we have in Python that do that for us? So there is one called Feature Engine, okay? Python package for feature engineering and selection. It can figure out which features are used and which features are unused. So sometimes you have, so this is one of the things you have to also think about in your in the Datathon. Find automated ways of doing this work. Do some of the legwork, do some of the domain expertise, but use tools that also help you do some of the automation. Some features are not that apparent if they're useful or not, right? So that's why we have algorithms such as PCA, etc. They figure out like what. Scikit-learn, definitely. Python package that includes processing, pre-processing and feature selection. And then there's another one called FeatureWise. Now, these are only three. These are only suggested. That doesn't mean that these are the only ones. Same thing with the previous tools that I've spoken about. You can use any tools you want, okay? But these are, let's say, the most famous one. Definitely Scikit-learn. Scikit-learn is your friend. Use it. Okay. Now, what people consider the most fun part, right? The modeling, okay? So this is where you, in the Datathon, this is where we're creating the solution. And you're going to be graded on the solution, okay? So what is modeling? Modeling is selecting a model, okay? The bare bone model, the untrained model. First, you have to select what kind of model you're going to be using, okay? Then you build the model. So building the model means training the model, okay? On the data that you've taken time to clean and feature extract and feature select and all that stuff. Then you validate your model. Now you have to validate it properly, okay? You can't just willy-nilly say, oh, it's working. One way of doing this is, and this is what you're going to be graded on. So I'm giving up some inside information. But validation is important. How you validate, and we're going to grade you on how you're going to be validating your model. If you're not validating it correctly and saying, look, it's working, it's 100% accurate, then I know there's something wrong. How did you get 100% accurate? Show me your validation process. If it's incorrect, then you should know why, okay? And then also you're going to be graded on deploying your model. So deploying model is the same as saying serving the model, right? So how you're going to be serving the model for the end user. So after you've trained your model, now your model is working and it can serve other people. Now you package it and serve it. Okay. So one way of deploying, we'll talk about the deploying processes later. Okay. So why do we do the modeling? We capture the pattern in the data, we provide the insight, and that therefore we do decision making. How do we do this modeling? So again, with the ML algorithm, machine learning algorithms, there are classification models. Okay. There is regression models, there is clustering models. Okay. Look them up, see what they do. Evaluation. How do you evaluate? For example, with classification, you use accuracy. Okay? You don't do that with the regression. You do it with classification. With regression, you use the mean square error. And then for clustering, there is many ways. One of them is the silhouette coefficient. Okay? Usually you look at also the elbow method, they call it. Okay? So there are many more. You need to be careful how you evaluate your model. Okay? Now, the evaluation is not about the procedure itself, or let's say the mathematical formula you're going to be using. It also depends on the data you're going to be using. Okay? I think I gave up too much information. All right, back to modeling. What tools do we have? We have, again, back to scikit-learn. Scikit-learn does a lot of things. It's an amazing tool. It's an amazing package. It does a lot of the pre-processing. It works amazingly in the pipeline. You have PyCaret, which is another Python carrot that automates the machine learning workflow. Flamel, it's a Microsoft Python package. It finds high quality models with low computational costs. And I also recommend this one, highly recommended, Auto sklearn. So this one goes through the sklearn algorithms, and it automatically chooses them. So this is some sort of AutoML in this case. AutoKeras. So who's familiar with Keras? Who knows what Keras is? Okay. We have only a few. Okay. So Keras is a layer above TensorFlow. Okay. And before it used to be a layer above Thano and TensorFlow. And TensorFlow and Thano are deep learning frameworks. So Keras makes it easy for you to build deep learning models. Okay. ML, library for AutoML. Okay. And Lazy Predict. Lazy Predict is another good one. I've used this a few times, really good. Okay, it goes through all the basic machine learning models, and then it gives you all the performances. Okay, of course, depending on what you're trying to solve. If you solve a regression problem, Lazy Predict will go through all the regression machine learning algorithms. If you're doing a classification, does the same thing. But note, Lazy Predict does not do the hyperparameter tuning. Okay, so it will give you a base of your models. Okay, and then you can go ahead and say, okay, this is these 2 or 3 are the best ones in terms of performance. Let me continue with the hyperparameter tuning. So then you can use Lazy Predict as a good starting point. Rather than you doing the legwork, Lazy Predict will cover a lot of steps for you. All right, finally. Well, it's not finally, it's a cycle, right? So it goes back again. The communication and visualization, okay? So here, what we're doing is, and this is what's going to happen in the competition as well. You're going to be displaying your findings. You're going to be displaying your findings using graphs, visualization, dashboards, reports, explanations, etc. Why do you do this? We want effective communication. We want actions to be taken further in the data science lifecycle. Maybe we need to reevaluate what we've done previously. So that's why we have the communication and visualization. Again, with tools that can do this. And here I emphasize app development, because you're going to be serving your model, and it's going to be also visualizing your model. Or let's say it's going to be, you'll be communicating your findings with that model. And you're going to be graded on that. So you can use Dash, Python framework for building web applications. You can use Panel is another one. Streamlit, very famous one. And then we have Nice GUI. This one I just recently found, and I thought it was easier than Streamlit as well. So Streamlit is not that bad. It just has a problem with a thing called states. I think people who work with React would know if it's what states are and what states fall in. So this is just a side note. Nice GUI does a really good job of working with states. Just a tidbit there. Okay. All right, and then back to the business understanding. As I said, it's a cycle. You evaluate the success of your model in the relationship to the business problem being asked. You tackle a problem identified. You obtain tangible or actionable solutions from that model, from that communication. And then if there are new insights, you can apply them to the next iteration of the data science lifecycle. Okay, so I'm stopping here and go to Google Colabs. Now I will share with you a sheet, a Google Colab sheet that is unfilled, so you guys can also practice and try out all the different packages that are available. Now, as I stated earlier, A lot of those packages already come pre-installed in Google Colab. Okay. Some of them, though, you need to install. And I've provided the code for installing them as well in Google Colab. So a thing called pip installing, if anyone's familiar with Python, some of them you have to just pip install them. So you, with these kind of commands, you have to put an exclamation mark because pip is not a Python command. It's a terminal command. Okay. All right. Testing. All right. All right. So in this Datathon workshop, I've created several collabs. Okay. I'll try to run through all of them. Some of them might take a while because of due to the installation. So what do I mean by due to the installation? So once you leave the Google Colab idle for some time, yeah, the state is reset. So then you have to reinstall everything again. So bear in mind this is. So for example, let me actually open another one. Sorry. Okay. So open up this one. So the classification using the Titanic dataset. Now, Titanic dataset, if anybody using Kaggle, anyone here? Kaggle? Okay, we have a few. So usually the Titan dataset is always the beginner dataset that's used. It's like an intro tutorial. So I use the same one. I use the Titanic dataset. So, and I split it up into as the same way I did with the business life, or the data science life cycle. So starting off with the business understanding, okay, business understanding. So we all know what our objective is. So for example, here, the primary objective when analyzing the Titanic data set is to understand the factors that influence the survival of passengers. So here we're doing some historical analysis. What type of people, okay, who survived the Titanic and who didn't, okay? And on what basis they did survive and what basis they did. So what demographic resulted in them surviving or not, okay? So we look at the objective, look at the value proposition. So studying the Titanic data set serves multiple purposes. First, it provides a gateway to learn about the nuances of data analysis and predicting models in the real world context, okay? The insight gained can be applied to modern scenarios in risk management, emergency response planning, etc. So this type of analysis can be used on a different set case, for example. So using this one, which is readily abundant, we have a lot of information. In addition to the data being clean, this is a huge factor. When data is clean, it makes life a lot easier. Okay. So the problem statement, we're presented with a classification problem. So what are the classifications I'm looking for in this case? Who can tell me from my explanation? Unless my explanation is really bad. What things am I trying to classify? Exactly. Okay. So it's a binary classification. Did you survive or you didn't survive? That's it. So it's a classification problem. I'm not trying to predict the age of the people who survived. I'm trying to predict who survived and who didn't survive. So first thing, we have the data collection. Let me open it up here. So the next thing is that the data is already available in CSV format. Now, with Google Colab, the nice thing is that these, as I mentioned earlier, these are text cells, and then these are called code cells. And in the code cell, there's always a play symbol here. So with the play symbol, or you can put Control Enter, you can run the code in isolation by itself, just that part. So now what's going to happen is I'm going to run it. Hopefully it works. Okay. So now this is showing that it's running. Okay, and now this check mark here, it's very small, means that it ran successfully. And now I have two variables. Okay, so first thing is I imported Panda. So I'm using Panda. Okay, and then here I called it as PD. This is the alias. So from now on, any function or class that I'm using from pandas is going to be PD. So PD dot. That's the accessor, PD dot. Okay. So now when I have PD, so that's read CSV. Read CSV is a function that is in the framework of pandas. And how does it work? It takes in the URL. Here it is, the URL. Now, probably it has more options, so we can look up the options by clicking on help. Let me do that here. You can do something like help, and then pd.read CSV. Okay, this is good to know how to understand the framework that you're working with. If you don't have documentation, obviously you're going to have documentation. But this is one way of doing it by just clicking here, and it tells you. Okay, so there's too much information. I'm just going to go to the signature of the function. Okay, so read CSV. Okay, so it needs a file path or a buffer. Okay, and the data type of that can be a file path, can be a read CSV buffer, or it can be a string as well. Okay, it could be a string. And I provided a string. This is a string. Okay, now let me delete this. I don't want it here. So now let's look at the data. Okay, so now the data is stored in a thing called data frame. And how do I know that this is a data frame? Again, I'll just do this. Print type of data. I run it. Is this large enough or is it small? Yeah, let me increase the size. No, I forgot how to increase this. It's not shown here. Oh, yeah. Purpose is a shortcut. Yeah, here it is. Thank you. Here it is. I think this is good. Okay. So if I run this, now it's a class here of data type data frame from the pandas framework, right? And then of course here we have different folders going into different modules or files, finally ending up with the data frame class. Okay. And by the way, pandas is open source. So one of the things you can do if you want, if you're interested, you can go into the repository and then you can check the code itself of how they created pandas. Okay. So now let's look at the data. What does it look like? So calling the head method, okay, a method is a function within a class, in this case. If I run it here, it will give me the first 4 or 5 rows of the data. Okay. So now, what information do I have? I have the passenger ID. I have if it's survived, if that person survived or not. So that's 0 or 1. The class of that student, where they stay, their economy, first class, I don't know what, they had different classes, and they put them as numerical fields. Okay. The name of the person, male or female, the age of the person. Did they have siblings in the with them in the that could be a factor, right? Were there did they have parents? The ticket ID, the fare price they paid, what's the number of the cabin? Embarked, I think this is the class of the entrance, if I'm not mistaken. In either case, there is I put I think the information for each one. In addition, if you go to the website itself, you'll also find the metadata of this information. Next, I want to find some information about the columns themselves. Okay, some statistics. Okay, so then I call the info method of that data frame. Okay, it's called data. All right. So if I run it, okay. So now the things that the information it gives me the name of the column, how many values does it have, okay, and of course they're all non-null. So this is all clean data. Okay, there's no null information. And then the type of the data, is it numerical? Is it a real number, float, or is it an object? Object usually is like a string. Okay. So here's a bunch of statistics. And then here there's a describe. Describe works only on numerical data. What does it describe do? It gives me the count, it gives me the mean of the data, it gives me the standard deviation, it gives me the minimum value. Now, with this statistics, I can figure out if there are any anomalies or if there is data that is way off. Okay, it gives me the 25 percentile, 50 percentile, 75 percentile, max. As you can see, it's only for the numerical data. Okay, the categorical data or the non-numerical data is not mentioned. For example, name. How do you get the mean value of a name? It's not possible. So it's skipped it. Okay. Oh, nice. Here we have it. So passenger ID, sex. Let's see. The number of siblings or spouses. P-arch is the number of parents or children. Fare, cabin, etc. Okay. Now we go to the data cleaning. Maybe we do need some minimal data cleaning in this case. So we need to look at the missing values. So the Titanic dataset often has missing values in columns like age, cabin, or embarked. Okay. So there is some information. Did we have missing information here? Let's see. Yes, I'm sorry, I did miss it here. So 714 values of age is filled. The rest is missing. Okay. Another one is the cabin. So 204 is only available. The rest is missing. So the majority of the data here is missing. Okay. And a few of the embarked. All right. So let's figure out what the missing data is. So again, is null is a method from the series. Okay. And then from that pandas series, I find the sum of the data for that particular series. Again, a series in pandas is a column. Okay. So I'm going to run this. As I said, age has 177 missing, cabin has 682, and embarked has only 2 missing. Okay. Now, let's look at the missing age data. Okay, the missing age. I want to know which rows are missing in this case. Okay, so here I have a few missing rows. So for example, passenger ID, survival, age is none. So now we have not applicable data. Same as null in Python. Okay, but none is used in, if I'm not mistaken, NumPy. Okay, so here's a few of them. So passenger 6 has a missing age, passenger 18 has a missing age, etc. Okay, so now I have to figure out, as part of the cleaning process, how do I fill in this missing data? One way is to add the median value. Okay, so the median value would be added instead of, so all of these will have the same value. They all have the median value. Okay, so who knows what's the difference between mean and median? What's the difference? Any ideas? So mean is the average, basically. Just the average. Median is the middle number, okay, or the average of 2 middle numbers if we have an even number of sorted numbers. Okay, so if for example, the mean of 1, 2, and 4 is going to be 1 plus 2 plus 4, which is 7, 3.5. That's the mean of those 3 numbers. If I have 1, 2, and 4, and I'm like asking for the median is going to be what? 2. So I'm going to fill in with the median value. Okay. And then I'm going to display those by using a specific index location of that row, or which row. So here again, going back to the original one. See here, I had no 8, I had 8, 28, 28. All of them the median age. Okay. Now, looking at the embarked, 2 missing rows. So I can fill in this missing values with the most common port. So I think that it's categorical. It's either S or Q, C, Q, or S. Okay. So I'm gonna miss it. I'm gonna fill it in with the most common one. In this case, it's gonna be the mode. Okay, mode is the most available So example, 1, 2, 2. What's the mode of 1, 2, 2? 2. Right. Then again, let's look at that data. And it seems that the mode is going to be the S. Okay. Now, with the cabins, anything that's missing, I'm just going to drop that one. So, part of the cleaning process, let's just drop it. Now, going back to my new data, so I should have all ages available, everything is available, it says. So when handling missing data, the key is to understand what data is missing and how to deal with it, okay? Now, another thing is we have categorical data. Some categorical data is ordinal, so there is order to it, okay? Other data doesn't have any order. So we have to figure out how to handle this kind of data. Should I convert it to numerical values, or should I use something called one-hot encoding, okay? So the rule of thumb, if the categorical data does not have order, convert it to one-hot encoding, okay? If it has order, then convert it to a numerical value. Makes it easy, okay? So going back again to sex, for example. Here, sex, for example, convert sex to a binary variable, either 0 or 1 for male. So I didn't use my my recommendation, but 0 and 1 is also fine for this case. So it can be numerical. Sometimes one-hot encoding is a waste. You don't want to, because with one-hot encoding, what's going to happen? Who knows what one-hot encoding is first? Okay, what is one-hot encoding? No, one is not available in one-hot encoding. Let's say given a concrete example. For example, in the embarked, we have 3 categories. We have C, S, and Q. How would you convert that to one-hot encoding? Okay, you're almost right. Yes. So what's going to happen is embarked is considered one feature. It's one column, right? With one-hot encoding, what you're going to be doing is you're going to be converting that one column into how many columns? 3 columns, exactly. So now you have 3 new columns. You have a C column, you have an S column, and then you have a Q column. And then each one of them will have either a value of 0 or 1. If it's 0, that means it's not available. It's not that. If it's 1, it's that. So then what's going to happen is you're making your data, let's say, less lean. Okay, you're going to have a fat, they call it a fat data set. And now you're having more features. Okay, sometimes having more features is an annoyance. So you want to use one-hot encoding, but you know, with the, let's say, try to avoid it as much as possible if you can. Okay. All right. So now we converted the sex here to female and male, 0 and 1. Okay, and then we click here, and then let's look at the sex column. They have 1s and 0s. Okay. Right, and then here just to check that we only have 0s and 1s and nothing else. Convert it into a data type, and set data types do not repeat in terms of values. Okay. Embark again, converted to a dummy variable. So this one is one-hot encoding again. So here we have a C, a Q, and an S, 3 columns. Right? Let's run it. Here we go. False, false, true. So one-hot encoding creates new columns. Label encoding converts each category into a number. So we did that with the sex, and then with the one-hot encoding, we did that with the embark. Okay. Outliers. So now here we use a little bit of statistics. Okay. Okay, we're almost going to be done here. What I'm going to be doing is I'm going to be sharing the Google Sheets for this one and the one that has missing data. Okay. So handling the outliers, again, we use a bit of statistics to find the Q1 and the QR. And then we do some visualization so that we can understand the data. This is part of the EDA. Okay, this is the EDA part of your competition. Okay, figure out the distribution of the data, where the data is coming from, what's it doing, etc. Like here, they told me that I have to finish soon, so I'm gonna skip this. Okay, so the EDA part of it, you can do it manually. Okay, Let me open it up. By using matplotlib, etc. You can also do your EDA with libraries such as Calib and Dataprep. Okay, and in this one, again, I urge you, or I suggest you run it yourself, try them out. Okay, let me do that now. I think we have it in Discord here. Discord, since we ran out of time. And I will share it, and I'll ask the organizers where to share it from. Okay, and I apologize that I couldn't cover everything. I hope this talk was useful, and thank you for attending and putting up with me. Thank you. Oh. Okay. There is also one announcement. I'll give it